people.
Ladies and gentlemen, thank you for my short introduction. There's a large list of colleagues that have been working on this project. The reason I'm showing that pump is specific in that we have got to a point in the project where we wanted to start testing out our integrated sensor devices on some equipment. So as you may know, the north wing of this building is this rather expensive nano fabrication lab. And when you go up the steps, you see it through the window. But in the basement of the building contains these water pumps and air conditioning systems and so forth. And of course, as you realize that if those pumps go down, then all of this equipment that we want to use is going to fail, which is a standard manufacturing challenge. And so it extends in a way to the kind of equipment that the California Energy Commission or the ISO or any of our developers would be creating. So we wanted to test out our equipment on the basic equipment. It's up in this. I don't know what. Yeah. I mean, you're just seeing this gigantic water pump. Well, it's not so gigantic. It's a big water pump, and the sensor that we built that's all working is on the very top there. It turns out that it's measuring the vibrations of this, and then using energy harvesting to also scavenge those vibrations and power this mode. And then we've been sending that out as part of our maintenance system. I'd like to embarrass Ron Hoffman, who joined us. He's in the back there, because he taught me and Carl 12 years ago now that everything we do should be reduced in cost. And he always taught me this 10 by 10 by 10 mantra. It was kind of like Ron's bumper sticker. In that everything we made in these meetings should be 10 times more capable, 10 times cheaper, and last for at least 10 years. So that was the sort of Ron Hoffman bumper sticker 12 years ago. And so this little talk I'm giving today relates to that. And as we go forward with this work, we're almost at the point where we've got these things working in such a way that we can make them on wafers in the lab, bring everything down that you've been seeing to a much, much cheaper MEMS scale, and make these kind of sensors, scavenging devices, and radios on the wafers, and integrate them in such a way that they would cost probably only a few dollars rather than tens of dollars, which is what they do now. In my next slide, this shows a integrated device. So we have been integrating our devices as part of this contract. This is a close-up, as you can see, of the top of that cooling pump again, and there's the device on the top. Everything in this arena works well, and in my next talk, which is in about half an hour from now, I'll describe more details of that. But just to show that this is our integrated device number one, the white area is a scavenging device. There's a coil here that picks up the vibrations of the motor, and then that's used to store energy in this capacitor here, and then to fire up the radio and controller system, which are here. You can see another view of it from the back here. Another integrated device that Jim Evans is going to focus on has been, again, integrating batteries, capacitors, and sensors and radios, which are these 4 blocks over here. And another group built this printed thermoelectric generator, which we can also make at wafer scale. So this second integrated device is a thermoelectric generator, which again you could imagine being used in a power plant near a gas turbine. This complicated looking graph here is just figuring out how the radio and the microcontroller work in the system. It's time along the bottom and then current draw here. And what you have to do is to generate electricity from the thermoelectric generator. The radio is sleeping for a while whilst everything is being collected, and also the sensor is making measurements. And then sooner or later you want to send out a radio signal. So I say it's kind of like going to the gym. This is the easy exercises here where you're just kind of getting warmed up. Sooner or later you want to go to the bench and press 145 pounds or something. There you have to have a big oomph to make the radio signal go. Then you're exhausted and you go back and you collect some energy for a while, and that's how this whole system fits together. Integrated device number 3, you've been seeing that in these talks. It's this tiny little, it's about the size of the little piece of rubber on the end of a pencil. It's about that kind of size. You can see it on a penny here. Here we've been using a GMR sensor to measure current, and that's been using a wide variety of the technologies that you've seen before in these previous slides. So what I'm most excited about is having done this work and integrating these 3 different devices. Before I hand over to my colleagues now, what is especially nice, you'll see it in Chris Sherman's talk, is that we have actually been fulfilling the idea that we can make everything on one wafer. Because this is a wafer that we made in our own lab here. This is out of the lab on the north side of the building. Chris Sherman has been the graduate student, who has been really working his tail off in the last 3 or 4 years getting this working. It's very difficult work. It requires a lot of scientific precision to make these wafers. In the middle are the microsensors that he has been making. These other areas here, you can just pick them out. The shape of them are the energy harvesters, and these bigger chips are the microcontrollers. So for the first time, in the last 6 months, we've been making these devices on a wafer. So just skimming through, I'm just skimming rudely through these slides now. You see we've gone from quite large devices that all work together. We've gone to smaller devices that Jim will describe that work together. We're getting to much smaller, other smaller devices that work together, and now we're getting to this near final wafer stage. The other thing I wanted to say in my introductory talks is that both these last 2 devices could easily be new companies like the Imprint Technology activity. And so we've been talking to our colleagues at the Energy Commission about trying to get a little bit more money to finish this project off, where this project here and this project here would be future devices that could be made in a company. And this is getting so close to our final fully integrated wafer of all of the components that we're hoping we can continue the project for a little bit longer. And when I'm talking here a year from now, you'll see these various components here fully integrated. And this would be our dream of a stick-on sensor that we can use in a wide variety of smart grid projects. So, Therese, with that short introduction, it's time for me to hand over to Igor for his last talk. As we're doing that, Rich did bring over, this is one of the flexible thermoelectric substrates. I'll leave it on the top of the podium here. This is really difficult. Mong brought this over today. Here are all these tiny, tiny devices that really are getting so small. I'm hesitant to pass them around, but the small printed circuit boards and the components that go with them. I'll leave these on the top here, and by all means have a glance at them as we move forward.